Now that we've practiced some volume problems, we're going to get into some volume application problems. So for each one of these, we're going to have to read it, carefully think about what we're going to do to get our final answer, because it's going to be probably more than just one volume calculation. And in this first one, it's also going to involve some work with getting a percentage. So for each problem, draw a diagram of the objects, include all dimensions, then compute the volume and include all work by using the 4 steps. This first problem, we already have the diagram here, so let's just read it. As an exercise for her art class, Mona has cast a plaster cube, 12 centimeters on each side. Her assignment is to carve the largest possible sphere from the cube. What percentage of the plaster will be carved away? So we need to really think about what we're doing here first. We're going to need a couple of volumes. We're going to need the volume of the cube, because that's one part of this, and we're going to carve away that cube so we can be left with the sphere. So another thing we might want to know then is what the volume of the sphere would be, because the most important thing here is to figure out how much we are carving away. So we're carving away a certain amount, and that would have to be the difference between these two. So we're going to be subtracting these two to get the amount that's being carved away from the cube to get down to the sphere. And then even after that, we're going to have to do a little bit of work, because then we need what percentage of the plaster was carved away. So once we have the amount that's carved away, we're going to have to divide that by the entire original amount to get what percentage it would be. So we've got a few things we need to accomplish here. Let's start with the volume of the cube. Remember, a cube is just a type of prism. So when we are looking at the volume of a cube, we'll take a look at the area of the base and multiply it times the height. We know a cube has the same dimensions on each side, so it's 12 centimeters by 12 centimeters by 12 centimeters. So the area of the base then would be 12 by 12, and then the height of the cube is going to be 12 as well. So 12 times 12 times 12 really is what we have here. So the total volume comes out to 1,728 cubed centimeters. So that's the volume of our cube. Let's go on and do the volume of the sphere. Remember, our sphere formula is 4/3 times pi times the radius cubed. All right, so what we need for the volume of the sphere is the radius. We're not given a radius here, but let's just think about this for a second. If this sphere fits perfectly inside of the cube, that means that the diameter of our sphere right here is going to be the same as the length of the box, or the cube, so that is 12 centimeters. So that means that the radius of our sphere is going to be half of that, or 6 centimeters. So we're going to have to use that 6 in our calculation for the radius and getting the volume of the sphere. So we've got 4/3 times pi times 6 cubed, and that would be 4/3. 6 cubed is 216, so 216 pi. We'll put the two numbers next to each other there. And well, pi is a number too, but we'll leave that kind of off on the side. And so our volume would be 4/3 times 216, so that's 288 pi cubed centimeters. All right, so let's make our calculation now for the amount that we're going to be carving away. As we said, we're going to be subtracting the volume of the cube and the volume of the sphere. We'll be subtracting these two numbers to get the amount that is being carved away. Let's do that on the bottom here. So we've got the volume carved away will be 1728. Oops, a little mistake there. Let's try that again. 1,728 cubic centimeters minus 288 pi cubic centimeters. And that gives you approximately 823.22 cubic centimeters that is carved away. Then our next question is, what percentage of the plaster will be carved away? Because that's really what our final answer is going to be, is what percentage of the plaster will be carved away. Now, percentage of the plaster carved away means we're going to take that amount that is being carved away out of the original cube that we're carving. So out of the 1728 up here, so the percentage will be 823.22 divided by 1728, 1,728. And when we do that, that is approximately 0.4764, which is approximately, rounding to the nearest percent, if you multiply that times 100, you would get about 48%. So our final answer for this problem is 48% of the cube is being carved away. On all these application problems, it's important to really think through what you need to do before you dive into it. Number 2 says that find the volume of a plastic. Find the volume of a plastic needed for this hollow toy component. The outer hemisphere diameter is 5 inches and the inner hemisphere diameter is 4 inches. All right, once again, let's think about what we need to do here. If we need the amount of plastic for this object right here, we're really going to be thinking about the spheres, because this is a hemisphere right here, but it's a hollow hemisphere, and the plastic is kind of like the amount that's on the outside, and then up to the amount that's, it's basically the thickness right there. Think of it as like a bowl. It's the thickness of that hemisphere. So we're going to take maybe the larger hemisphere with the 5-inch diameter and then subtract out the inner hemisphere with the 4-inch diameter, and then the amount that's left will be the difference between the two, and that will be how much plastic that we need. So we're going to do another subtraction problem. All right, so volume of the outer hemisphere is what we will do first here. So the volume of the outer hemisphere. So once again, the volume of a sphere is 4/3 times pi times the radius cubed. Now we are going to have to divide that answer by 2 in the end to get the hemisphere. I think I'm going to start off with the 4/3 pi r cubed and then divide by 2 at the end of the problem. So in this particular problem, we're looking at the outer hemisphere, and that would be a radius of 2.5. So the diameter is 5, so the radius is 2.5. So that's going to be our radius that we're going to use. So 4/3 times pi times 2.5 cubed. Again, we'll divide that by 2 at the end. All right. So 4/3 times pi times 2.5 cubed. If you take 4/3 times 2.5 cubed, that's going to be a fraction. It's going to be like 20 and 5/6. Let's see, 20.83 repeating pi is what we get there, inches cubed, and then we'll divide that by 2. So we take that and divide it by 2 so we get the hemisphere. That is approximately 32.72 cube inches. So that is the volume of that outer hemisphere. Let's now find the volume of the inner hemisphere. So volume of inner hemisphere. Same sort of calculation. We're going to take the volume, which is 4/3 times pi times r cubed, and it is a hemisphere, so we'll divide that by 2. And this time the radius, notice the diameter is 4, so the radius of this one would be 2. So 2 is going to be the radius that we're going to use. So 4/3 times pi times 2 cubed. And again, we're dividing by 2 at the end since it's a hemisphere. All right. So 4/3 times 2 cubed. 2 cubed is 8. So you basically have 4/3 times 8 times pi. And when you do that, you get 10 and 2/3 or 10.6 repeating pi. And then we're going to divide that by 2. And we get the volume approximately equal to 16.76 cube inches. Well, the final calculation then is going to be the difference between the two. So down at the bottom, let's go ahead and subtract these now. So volume of plastic is 32.72 minus 16.76, and that is about 16 inches. If we're rounding, or cubic inches, I should say, if we're rounding to the nearest whole number, so that's about 16 cubed inches. One more problem that we're going to do here. On the next page. Says if you roll an 8.5 by 11 inch piece of paper, a typical piece of paper, into a cylinder by bringing the two longer sides together, you get a tall, thin cylinder. If you roll the 8.5 by 11 inch piece of paper into a cylinder, bringing the two shorter sides together, you get a short, fat cylinder. Which one of the two cylinders has the greater volume? So if you take a piece of paper and make a bigger, longer, or a taller, longer cylinder, is that the same volume as if you turn it 90 degrees and put the two short sides together and create a shorter, less tall, shorter, fatter sort of cylinder? Let's take a look at what we have here. So first off, let's sketch this problem. So we've got a taller cylinder, and so we're drawing a cylinder. We're going to try to make the best we can two little congruent ovals, and then we'll kind of connect them together here. So we just got to do the best we can with our sketch here. For me on the board, it's a little bit tough sometimes, but hopefully that's okay for you. All right. Now this one's sort of interesting because we are going to need the area of the base times the height. Okay? That's what our volume is going to be. But we're not given enough information yet for the area of the base here. We do know that the height of this is 11 inches, but we still need to get a radius for our base because we're going to need to do pi r squared for the base here. All right, well, let's think about what we would do here. We know that the circumference of that base is 8.5 inches. Right? So if we know the circumference of that base is 8.5 inches, we should be able to track down the radius. Right? So that's actually the first calculation that we're going to make. Let's go ahead and go through and get the radius of this. So circumference, we know, is equal to pi times diameter. All right, in this case, we have the circumference of the base is 8.5. So 8.5 is equal to pi times diameter. And now let's solve for the diameter by dividing both sides by pi. So if you take 8.5 and divide it by pi, you get about 2.7. All right, more precisely, let's take it out of a few more decimal places. So maybe about 2.71. So about 2.71 would be our diameter. So then our radius, of course, is going to be half of that. So if we take that and divide it by 2, we'll get our radius. And so that's about 1.35 is what it works out to. We take it out to a couple decimal places. So about 1.35 inches. And so then, well, you know what, let's take it out one more space. Let's take it out to maybe 1.353. Like I've said before, we want to try to not use rounded answers to make another calculation. And if we are going to use a rounded answer, like I kind of am doing here, let's take it out to a number of decimal places so we can make it as precise as possible. All right, so the volume is going to be the area of the base times the height. So the area of the base is going to be pi times 1.353 squared. That's the area of the base, pi r squared, times the height of 11. So pi times 1.353 squared times 11, that's going to be approximately 63.2 cube inches. All right, so that's the volume of that cylinder. Now let's do the volume. If we flip this 90 degrees, we're going to have a cylinder that has a larger base but is shorter. All right, so we're going to just sketch that out. So our cylinder this time, we know if we flip it over, then this is going to be our 8.5 inches. And once again, we know the circumference of our base because we wrapped our paper around. We know it's 8.5 by 11 inch piece of paper. So we know that circumference right there, the circumference is 11 inch circumference. Since we know it's 11-inch circumference, we should be able to get the radius. So we'll do the same things we did in the last problem. So circumference is equal to pi times diameter. Our circumference is 11, so 11 is equal to pi times diameter. We're going to divide both sides by pi. So 11 divided by pi would be our first part of our answer here. So 11 divided by pi is 3.501. So our diameter is about 3.501 inches. And of course, we're going to divide that by 2 to get the radius. So divided by 2, you get 1.751 approximately. So 1.751 approximately will be our radius for our 1.751 inches. The radius of the base. Okay, so now let's go ahead and get the volume. Once again, volume is the area of the base times the height. So the volume of this base is a circle. So pi times 1.751 squared, that's the area of the base, times the height, which in this case is 8.5 inches. So that's something we can just punch into our calculator and worked out. That is approximately equal to 81.8 cube inches. All right, so our two volumes, 63.2 cube inches, 81.8 cube inches. Which one of these cylinders would have a larger volume? The second one. All right, the shorter one, but with the larger base. So, the larger volume. And that completes our practice application problems for today.